The last in-class participation, and here is question 1. We have a data file that gives us all these random pieces of information, and we want to use the nominal market returns to compute the arithmetic, geometric, and standard deviations of nominal returns. So we have, oops, I need to hide this. This is the solution. This is the S&P return index, and to compute the nominal returns, an easy way to do this is to hide some of these rows. So if you select the number here and kind of click and drag down, then you can right click and hide it, and that just makes it easier to deal with. Alright, so the return from period to period is the price that we sold it at minus the price we bought it at, divided by the price we bought it at minus 1. Actually, not minus 1. Just regular. And these are all of the returns, so if we were to unhide this, in fact, let me change this to percent just to talk about it. Okay, so a good way to smell check it is the return is 27%, and that looks about right. So if we look at 142 minus 111, and if we bought in at 111, we make approximately 27%, that makes sense. So what you want to do is make sure that there's nothing weird here. So if we bought in at 1049, it would go down to 998, and therefore that's a minus 4%. So all of this makes reasonable sense. Oops, 1 plus nominal. We're going to need that to get the answer. Okay, the arithmetic is just going to be the average. The standard deviation is just going to be standard deviation, STDEV. And then the geometric so we can use the product of the 1 plus all of these, and we're going to have to do some changes, but let's go ahead and get that. There are, so number of periods. I don't think I've ever actually taught you guys this in class, but you can count the number of times numbers appear. So there are 25 years of data here. And so this means that the geometric return is going to be this to the power of 1 over 25 minus 1. Put this in percent terms. Put this in percent terms. And let me just highlight these so that we can all see what's happening. All right, the arithmetic nominal return is 10.81, the standard deviation is 18.8%, and the geometric mean is 9.18%. Let's just check our solution here. 10, 9, and 18, and they're also 25 years. The intuition here, the reason it's different is because the geometric takes into effect compounding. In this case, it's lower. And the standard deviation tells us what the sort of variance is. So notice we have some years that the market went up crazy and other years where it goes down. So on average, it's about an 18% standard deviation. And I think that's all we have on this question.